एक कंटिन्यू हमसे मांग रहा है।
हाँ ओके कर दीजिए, कंटिन्यू कर दीजिए।
कर दिया।
So friends, today we are going to have a very unique session in this master's class series by Anil Risal Singh sir, and that is on the light. And Dhanbad Camera Club, and especially on behalf of Dhanbad Camera Club, I am very much thankful to him that he accepted my request to work on light, and he has worked for a couple of weeks. And today we are going to have the, you can say, premiere of his presentation at this platform. About Anil Risal Singh, I don't need to say much because everyone knows him very well. But just I will brief some of his, you can say, big achievements in his career. You know everyone that he has got MPF, ARPS, honorary FIP, honorary LCC, FFIP, AIPC, and at the same time he was also conferred with honorary fellow of Dhanbad Camera Club in March this year. Since last 45 years, he is exploring the creative possibilities using the medium of photography, and you have seen his way of seeing the subject very closely. It may be architecture, it may be a landscape, it may be a tree trunk or anything. He goes very close and he comes out with a forms and textures. That is his specialty and unique kind of photography he is doing. He is ex-president of FIP and retired as head photo division, National Research Laboratory for Conservation of Cultural Property, Ministry of Culture, Government of India. He is president of Lucknow Camera Club. He was chairman of the jury for National Photographic Awards, Ministry of Information and Broadcasting, Government of India in 2015, and that is one of his remarkable achievement during his career as a photographer. He is also Nikon expert. Now, friends, just a minute. I will share my screen and I would like to show some of his visual introduction because just a minute. I am sharing my screen. Just a minute. My screen is visible to all?
Yeah.
Yeah.
Yes, sir.
Dhanbad Camera Club is very fortunate to have his association number of times. In 1992, he was a jury for the Dhanbad Photographic Association's International Salon. Then in 2018, he was the chief guest of our DCC World Photographic Day. And in the same year, he was also jury for DCC photo contest. He also presented a seminar at IIT Dhanbad in 2018 only. In 2019, also he was here in Dhanbad as a jury member for JCM International Salon Judging at DCC Dhanbad. You can see some of his pictures taken candid during his visit to Dhanbad. This is in 2018. In the extreme left, he is the Salivahan Srivastava, President of Photo Freak IIT Dhanbad. He is Gopesh Kumar, Head of the Photography Division IIT Dhanbad. This is a group photograph during World Photographic Day celebration of Dhanbad Camera Club. Award ceremony of photography contest. In this frame, in the extreme right, is the Director General of DGMS, Sri P.K. Sharma. This is during a photo walk in nearby area of Dhanbad, that is the Dhobi Ghat, very close to Baitan. Group photograph at Dhobi Ghat, Baitan. And it was a very, you can say, touchy moment when he left Dhanbad after his visit. In 2019 as jury member. Here you can see Sri Jain Singh, senior photographer from Dhanbad. Akhil Hadia ji bhi पीछे हैं. This is how he goes very close to a subject. This is a scrap yard of municipality of Dhanbad, and here I thought it may be of his interest, and he went there, and the kind of image he brought out, it is remarkable. This is the image he captured, and this is the frame in larger size, and this is what he saw. And then because of his association and very close rapport with our club, our governing body decided to appoint him as chief advisor, and we are very much thankful to him that he accepted our request. This is the set of pictures submitted for MFF by Sri Anil Risal Singh sir. See his vision, is just remarkable. This is some glances I could get it from that National Photography Award ceremony in Delhi. The chairman of the jury board. We can see Shivji Joshi sir. And then recently we had some international legendary photo webinar from August 2020 to March 2021. During this period, we also conferred honorary fellowship and associateship to a few of legendary photographers. In the same sequence, we conferred honorary fellowship of Dhanbad Camera Club to Anil Risal Singh sir in the month of March 2021. That's all. So thanks friend, all request Anil sir to share his screen and show the light, the variety of light and all. Please.
Thank you. Thank you so very much, Mukesh ji, for your pictorial introduction of mine. I really enjoyed seeing those visuals. Friends, good evening and namaskar. I welcome you all to this webinar by Dhanbad Camera Club. I would like to thank Dhanbad Camera Club and its president, Mr. Mukesh Srivastava, for giving me this opportunity to interact with you with the subject, the light. And now, friends, this is the time to share my screen. Can you see the screen?
Yes, sir. Yes, sir.
Okay. So today's topic is the light. We photographers know the importance of light. And when I have started preparation for this talk on light, the first slide which I would like to have within this presentation is Tamso Ma Jyotirgamay. मुझे अंधकार से निकाल कर प्रकाश की ओर ले चलो, सत्य से असत्य से सत्य की ओर ले चलो. Take me away from darkness to light. Lead me to the enlightenment from ignorance. These three words, Tamso Ma Jyotirgamay, it is having the philosophy of the light. मुझे अंधकार से निकाल कर प्रकाश की ओर ले चलो, असत्य से सत्य की ओर ले चलो. So I thought the very first slide of my presentation will be this, Tamso Ma Jyotirgamay. Friends, we all know sun radiating the energy mainly as visible light. It is by far the most important source of energy for life on earth. We all know this fact very well. Importance of light for life. The main and biggest source of light on earth is the sun. Obviously, natural light, daylight or sunlight is the biggest source of light and also origin of life on earth. Sunlight provides energy that green plants use to create sugar, mostly in the form of starches, which releases energy into the living things that digest them. The process is called photosynthesis. We all know this, which provides virtually all the energy used by living things. Without light, life is not possible. It is very likely that without light, animal, plant, and human life would not have even existed. We all know this fact. And here I would like to quote from the Holy Book of Bible. It is written over there, in the beginning, when God created heavens and the earth was formless and void and covered by darkness. The first book of Bible, that is Genesis, first chapter, verse 3, it is written over there, then God said, let there be light. This 4-word sentence I like very much. It is having some rhythmical touch for me. And many of my photographs I title, let there be light. So I'll, again, then God said, let there be light, and there was light. And God saw that light was good. And God separated the light from the darkness. So when God was creating this earth, the first thing he did, separating the light from the darkness. So that is the very, very important thing. And as I have said, I have titled few of my pictures on this sentence, let there be light. And I hope here I'll be presenting 3 or 4 of my pictures, which I think will represent this phrase, let there be light. Let there be light. Light emerging from the darkness. Let there be light. Let there be light. And the last one, it is symbolizes light. Let there be light. God Almighty resides within all humans as light. A fact this is supported by all scriptures, by all religions. Light is used to symbolize God, truth, and holiness in various scriptures of the different, or you can say the every religion. This is very important. This is the few things that is very common in every religion. Light used to symbolize God, truth, and holiness. Uh, I'm not able to. Yes. In Bhagavad Gita, Shri Krishna ji said, "Of lights, I am the radiant sun." So, as I said, the God, light is the symbol of God, and it is written in the Bhagavad Gita. I'll again share the soul maintains this material body, and light is the very, very important thing in every religion. And in Ramayana, it is said the sun's power, which is light, in removing the darkness of night is incomparable. And this is a shlok from the Bhagavad Gita. The meaning of this shlok is, he is the source of light in all luminous objects. He is beyond the darkness of matter and is unmanifested. He is knowledge. He is object of knowledge, and he is the goal of knowledge. He is situated in everyone's heart in the form of light. In Bhagavad Gita, it is stated. In Islam also, it is written in Quran, the importance of light. It emphasizes the importance of light. Allah is light of heavens and the earth. Light, a symbol of Islamic faith, splendor, light, and nur, adieu, appears numerous times in the Quran as the metaphor for the revelation that gave the world Islam and that continues to enlighten the believers. And in Christianity, it is said by the Jesus in the book of John, 8th chapter, 12th verse, when Jesus spoke again to the people, he said, "I am the light of the world. Whoever follows me will never walk in the darkness, but will have the light of life." And another, I have already shared this, but again, I would like to have it. In the beginning, when God created heavens and earth, the earth was formless, void, and covered by darkness. Then God said, "Let there be light." And there was light. And God saw that the light was good. And God separated light from the darkness. In Buddhism also, Buddha once said, if you light a lamp for someone else, it will also brighten your path. Yes, very, very right saying. And the Buddha's last word were, be your own light. The truth is light. So we see in all religion, the importance of light is emphasized in the great way. You can say the God, holiness, and truth. Light is the metaphor of that, synonym of God, holiness, and truth, which is light. In Sikhism, it is said, Guru Nanak said, the body is the place, the temple, and the house of God, in which he has placed his infinite light, says Guru Nanak Ji. So, I mean to say, by seeing these mythological aspects or facts regarding the light, that in all religion give the equal importance to light. And I'll quote here Sant Kabir, the creation is born of light. and the light is in creation. Very, very true. The creation is born of light and the light is in creation. So friends, when we talk about the light sources, the ancient light sources, or in natural category, we have sun, of course, the biggest light source, then moon. Moon is not having its own light, it is illuminated by the light of the sun. But when moon illuminates, we know it is indirectly light of the sun. Stars also emit some light, and lightning also. बिजली कड़कती है तो रोशनी होती है. An ancient man-made source is fire. Fire used to give us light. Then present light source. Natural light source are the same: sun, moon, stars, and lightning. Some insects also emit light. Some fishes also emit light. And man-made light sources are fire, of course, the incandescent lamps, fluorescent lamps, CFLs, LEDs, LED studio lights, flash, and studio stoves, etc., etc., etc. What is light? This is a very big question. What is light? Light is energy. Light is the latent energy, or we can say light is the radiant energy. Light is photons of energy. Light is electromagnetic spectrum or radiation. This is more scientific when we say light is the electromagnetic spectrum or radiation. In physics, the term light refers to electromagnetic radiation of any wavelength, whether visible or non-visible. So visible rays, ultraviolet, infrared, these ultraviolet and infrared rays human eye cannot see. So these two comes in the category of non-visible spectrum. So visible rays, ultraviolet, infrared, gamma rays, X-rays, microwaves, and radio waves are all the part of light. In fact, is light. You need not become a physicist to be a photographer, but a little understanding of the properties of light can be beneficial to photographers' work. So those things I'll be discussing over here in very brief. This is the chart of electromagnetic, the whole electromagnetic radiation. The visible spectrum is having very, very small portion in this electromagnetic radiation. Only this much of part of the light human eye can see. And by seeing this visual, we can see shortest wavelength having the higher frequency and the higher energy. On the left-hand side, when wavelength is short, the frequency is higher and energy is higher. When we move from the longest wavelength, it is having the lower frequency and the lower energy. Here we can see the visible spectrum is around about 400 to 700 nanometer. Nanometer is the unit of wavelength. So this portion, it is actually 380 to 700 nanometer, the visible spectrum, which human eye can see. All the other part of the spectrum, human eye cannot see. Now, it is more specifically, more evident in this visual. Lighting is a form of energy. We have already discussed it, without which there can be no vision. Yes, very true. When light strikes an object, it may be reflected, absorbed, or allowed to pass through. Three things can happen when light strike an object. And this is when the surface, on the smooth surface or shiny surface, is bounces off in one particular direction. This bouncing of light is called the reflection of light. You can see, number one, light is being reflected. Number two, when light falls on transparent object, it is transmitted to the other side. That is why we can see across transparent subject. Number two, light is being transmitted from the transparent subject. Third, when light falls on the rough opaque objects, most part of this light is absorbed and changed into the heat energy. A black surface absorbs almost all the light. That's why it looks black. When most of the light is being absorbed by the object, it looks on the darker side. So this is a phenomena when light strikes different surfaces. Properties of light. Generally, we can say light travels in a straight line. Yes. Light travels faster than sound. Yes. We see things because it reflects into our eyes. Yes. From the subject, light falls on the subject, then it reflected and we can see it. Shadows are formed when light is blocked by an object. When light is incident upon an object, some are absorbed and some are reflected. Yes, a part of the light falling on any object, some part of it being absorbed by the subject and some part of it being reflected. Another classification of the properties of light. Light travels very fast. Yes, approximately 1,86,282 miles per second in vacuum. Very fast. Light has a dual nature. Light travels in straight lines. Light can vary in intensity. In different mediums, light's intensity can vary. Light interacts with the matter, yes. Light is comprised of many colors. We all know our light comprises of 7 colors. Light carries energy and information. This is very important. Light carries energy and at the same time information. Properties of light can be classified: effect of material on light, reflection, refraction, dispersion, diffraction, and dispersion, scattering of light, and polarization of light. In very brief, we'll discuss these different properties of light. Effect of material on light. I have already said materials can be classified based on how it responds to light incident on them. Opaque material absorb light, do not let light to pass through. Transparent material allows light to easily pass through them. Translucent material allows light to pass through but distorts the light during the passage. Reflection. Light follows the law of reflection. The angle of incidence is equal to the angle of reflection. This is the common principle of light, we all know. Light can bounce off material in 2 ways. Diffuse reflection. Reflected rays go in different directions, happens in rough textured or uneven surfaces. Regular or specular reflection. Reflected rays go in one direction, happens in a smooth and shiny surface. Image can be seen here. Now the refraction. Light travels faster in air, slow in water, and slower still in glass. The slower light is in a medium, the more it refracts band in it. The measure of how much light refracts in a medium is called the index of refraction. In the next slide, it may be more clear. A line that is perpendicular to the water surface is called the normal. You can see the vertical line. When the light ray passes from air into water, it slows down and bends towards the normal. You can see the red light path. When it enters from air to the water, it bends towards the normal. That is called the refraction. And then diffraction. This is defined as the bending of light waves around obstacles in its path. Example, when light waves passes through a barrier with a small opening, it acts as the single point source from where light emerges and spreads in all directions. And dispersion, the process in which light is separated into its color due to the differences in the degree of refraction. We all know about how the rainbow used to form. White light comprises of the 7 colors. And when this 7 color pass through a prism, it splits into the 7 colors, which is called the vibgyors: violet, indigo, blue, green, green, yellow, orange, and red. So these are the 7 colors which made the white light. Here you can see when the white light passes from the glass prism, it is used to split in the 7 colors. The splitting of white light into the components color is called the dispersion of light. Sunlight is often called white light, although it is a combination of the different colors, 7 colors. We can see these colors in a rainbow. These colors are red, orange, yellow, green, blue, indigo, and violet, as I said. Scattering of light. Scattering occurs in such condition where the surface of the obstacle is rough. In addition to this, the surface dimension should be small compared to the wavelength. Analyzing the scattering have the vital role in radar application, but in photography also. When the surface is smooth, we have the specular reflection, but when surface is rough, it is scattered. Light used to scatter in all directions. And then polarization of light. This is very important for us photographers. Light is the interaction of electric and magnetic fields traveling through a space. The electric and magnetic variations of the light wave occur perpendicular to each other. The electric field moves in one direction and magnetic in another, though always perpendicular to each other. So we have one plane occupied by an electric field, the magnetic field perpendicular to it, and the direction of travel which is perpendicular to both. These electric and magnetic vibration can occur in numerous planes. Through this diagram, we can understand the sunlight is the unpolarized light. It is having the magnetic electronic field and the magnetic field perpendicular to each other. When we use the polarizer, when we put the polarizer on the lens, only light in one direction can pass through. And that's why we have the polarized light. And polarized light is very beneficial for photographers. It cuts the reflection. Except the metallic reflection, the polarization of light cut every kind of reflection. This is a very important phenomena for us photographers, and that's why the use of polarizer in some condition is the must. When I do the landscape photography on the mountains or hills, I always put polarizer into my camera. Human eyes can only see a very tiny portion of what is called the electromagnetic spectrum of light, and that portion we call the visible light. We all know that it is called the visible light. Visible spectrum, this is 400 to 760 nanometer, and the daylight is from the range 300 to 500 nanometer. Invisible spectrums, the ultraviolet is invisible. It is 200 to 400. In fact, it is lower than 200. That will I'll tell you later on. And the infrared from 760 to 900 nanometers or higher. Ultraviolet and infrared spectral both are invisible to human eye. Here you can again see the same thing. In fact, ultraviolet, the range of ultraviolet is from 10 to 400 nanometers. There are different types of the ultraviolet. The longest ultraviolet are of photographic use. We will see when we go further in this presentation. This is again the same thing. It is said, if there is no light, there won't be any sense of seeing. It is also said, if there is no light, no photography is possible. This These two statements are true, but only 99% true. With infrared equipment in total darkness, even things may be seen. Human eye can see in total darkness with infrared equipment. In total darkness, photography is possible with infrared rays. So when we say that if there is no light, there is no sense of seeing, and if there is no light, no photography is possible, it is only 99% true. Because with infrared, these in darkness, human eye can see, and with infrared rays, even in the darkness, photography is possible. Hot objects, including the human bodies, give off some heat in the form of the infrared light. And that heat is captured by infrared equipment, and we can see in the darkness even. Night vision goggles use thermal imaging technology to capture that infrared light. This way, you can see an image of what's going on in the dark. It's based on the amount of the heat which is being made by the object. These are all infrared equipment. A night vision device, NVD we call, also known as a night optical observation device, and night vision goggles, is an optoelectronic device that allows images to be produced in levels of light approaching total darkness. The image may be a conversion to visible light of both visible light and the near infrared, while by convention detection of thermal infrared is denoted the thermal imaging. The image produces typically monochrome. These are some of the thermal night vision devices you can see. And usage of infrared. Infrared radiation is often used in industrial, scientific, military, law enforcement, and medical applications. Infrared, heat or thermal rays. Light is used by electronic heaters, cookers for cooking food, short-range communications like remote controls, optical fibers, security systems, and thermal imaging cameras which detect people in the darkness. It is called the night vision devices. Images taken with infrared rays serve a number of scientific and medical or artistic purposes. Images may reveal deterioration of art, work, or structure not apparent under the visible light. This is it is having very important, we talk about archaeological and museum objects or conservation of art objects. These are the thermal night vision technology by the infrared equipment. In the light, we can see, yes. Infrared photography is also used to make the unusual landscapes. When we do infrared photography, we put a filter which absorbs all the visible light. Only infrared rays allowed to pass through the filter to the lens, to the film or sensitive surface. And some unusual, the heat radiation from the subjects make the image. So by infrared photography, we used to have very unusual landscape. Another example of that. So it is a very interesting to do landscape photography with infrared infrared rays. When we were using the analog system of the camera film, when we were using film for infrared, there used to be the special film. Ordinary film could not be used for infrared photography in those days. There used to be the special infrared films in black and white as well color. As I said, it is very much useful in the conservation of the museum and archaeological material or objects. Here we take the example of paintings. Paintings used to have three layers: surface layer, it is called the upper layer, the pigment layer, the middle layer, and the ground or support layer, the lowermost layer. When we require information which is beyond to get by the normal photography. Ultraviolet photography, infrared photography, and X-ray photography used to come into the picture. We do photography by using these three techniques. Infrared reflected photography. In very brief, I'll discuss. It may be little theoretical, maybe a little boring. When we are talking about the light, these different aspects of portions of the light we should discuss about. But I'll discuss in very brief. Infrared reflected photography. Infrared lights have the longer wavelength than the visible light, allowing the materials to become transparent when they are opaque to visible light, including paint and oils. Kodak Retin 87 filter used on the lens of the camera. This Kodak Retin 87 filter absorbs visible and ultraviolet spectrum, only allowed to pass infrared spectrum or infrared light. This is our rough sketch, infrared reflected photography. Here you can see on the lens of the camera, Kodak Retin 87 filter is placed. It absorbs the visible and ultraviolet spectrum. It only allows the infrared rays only. So light source, putting light on the object, in this case it is the painting, and when light reflects from the painting, the filter Kodak Retin 87, which is already there on the lens of the camera, absorb all visible and ultraviolet spectrum, only allow infrared photography. As I have said, infrared having the penetrating property, so it gives information which cannot be seen by the visible light photography, and that's why this infrared photography is very, very important. And infrared reflected photography or infrared reflectography, these are two different terminology of the same thing. Infrared reflected photography is called infrared reflectography by art conservators. Can be applied to painting on various mediums to reveal the underlayer in non-destructive manner. This information is useful in deciding whether the painting is an original version by the original artist or a copy. This is very important. By the infrared reflected photography, we can know this, that this is the original painting or it is a fake or it is a copy. Here, the infrared reflected photography. On the left-hand side, painting under normal light, normal visible light. On the right-hand side, painting under the infrared rays, causing different illumination of the paint pigment. The later retouching, here, the arrow you can say, it is having the different illumination. It is because of the difference of paint pigment. It is only possible to capture by infrared reflected photography. That's why infrared reflected photography is very important when we talk about the photography of the museum and archaeological object and the conservation photography. Then infrared luminance photography. In infrared luminance photography, Corning glass filter 9780 on the light source, which absorb the infrared spectrum. It allows to pass the visible light. The Kodak Retin 87 filter on the lens of the camera, which observes all visible light, but luminance produced in the infrared spectrum can pass through it. We can see like this. This is the infrared luminance photography. On the light source, the Corning glass filter 9780 absorbs the infrared spectrum. And when light was fall on the painting and then reflected back on the camera, Kodak Retin 87 filter, it absorbs the visible and ultraviolet spectrum. It allows infrared rays in luminance, and the result may be like this. On the left-hand side, it is illuminated by LED and the tungsten lamp. On the right-hand side, it is with the LED light only. This is having the different luminance. It is showing the portion which was retouched in the painting, the brighter portion. So this infrared reflected photography and infrared luminance photography is very, very useful in conservation of the art object films. Now about the ultraviolet. Ultraviolet is a form of electromagnetic radiation with the wavelength from 10 nanometers to 400 nanometers. But the longer wavelength ultraviolets are useful for ultraviolet photography only. Shorter than that of visible light, but longer than the X-rays. UV radiation is present in sunlight and constitutes about 10% of the total electromagnetic radiation output from the sun. We all know that. Ultraviolet photography, the reflected ultraviolet photographic technique records only ultraviolet radiation in the region of 320 to 390 nanometers only. This is called the long wave ultraviolet reflected from the subject. UV light only penetrates 50 micron into the painting. The penetration by the infrared is more deeper, but from UP light, the penetration is only 50 micron. The light was rather weak, not able to pass through the larger quantity of paint. Here comes infrared photography very handy. Infrared can be used to look underneath a painting to observe what lies below the paint. These are the different ultraviolet light rays, near ultraviolet or long ultraviolet. In our atmosphere, in the outer atmosphere, there is the ozone layer. This range, 515 to 400 nanometers, is not absorbed by ozone. The next range, which is called the middle ultraviolet, which comes under 280 to 350 nanometer, mostly absorbed by the ozone. This is very harmful. This middle ultraviolet is very harmful to the human skin. And when by pollution or other things, the ozone layer of our atmosphere is damaged, then this middle ultraviolet can also pass through the atmosphere. And that's why we are having the skin diseases when this middle ultraviolet our skin used to expose to middle ultraviolet due to the ozone layer destruction. And then the far ultraviolet, this is 100 to 280. This is completely absorbed by the ozone. And then farthest ultraviolet, which is 10 to 100 nanometer, this portion is strongly absorbed by the atmospheric oxygen. So only the near ultraviolet, which is 315 to 400 nanometer, which is not absorbed by the ozone, we use in the ultraviolet photography. This is, you can see, the UVA is not absorbed by ozone. It goes very deep into our skin and can damage. Then the B range, 280 to 315, mostly absorbed by the ozone. So it cannot harm our skin. Then the further 100 to 280 nanometer completely absorbed by the ozone layer. So वो हमारे पास तक नहीं आ सकती है. So this one, ultraviolet A, under the wavelength of 315 to 400 is most can, with the sunlight, can come through the ozone layer, and this portion only of the light ultraviolet we can use for ultraviolet photography mainly. Here you can see this near ultraviolet in the range of 315 to 400 nanometer. It can go deep into up to the dermis layer of our skin and damage it. Again, the same thing. Most of the harmful ultraviolet is absorbed by the ozone layer and other gases of the atmosphere, but this long wave ultraviolet can pass through the ozone layer. Uses of ultraviolet photography. Ultraviolet photography is a photographic process of recording images by using light from the ultraviolet spectrum only. Images taken with ultraviolet light serve a number of scientific, medical, or artistic purposes. Images may reveal deterioration of artworks or structures not apparent under the visible light. This is for the medical purpose, this ultraviolet photography. Ultraviolet imaging technology used to show that sun damage can happen to human skin. On the left-hand side, the skin under the normal light condition, but when we examine this under the ultraviolet radiation, we can see the damage of the skin due to the ultraviolet radiation. So it is very much very importantly used for medical purposes, ultraviolet photography. Now, this is ultraviolet photography used by the photographer for their creation of artwork. To reveal the retouching in the artwork. These are two examples. On the left-hand side, painting. First, we'll see on the right-hand side, painting under normal light condition or normal photography is being done. On the left-hand side, painting with ultraviolet light rays. It is showing the repainted areas which cannot be seen by the normal visible light. We can, on the right-hand side, a photograph taken with the normal visible light, but by using the ultraviolet radiation, the retouched area can be seen. That's why it is very useful in conservation of art materials. Again, the same thing, I have already described it. So painting is having 3 layers: surface, pigment, and ground layer. And for the surface, ultraviolet, then the middle layer, infrared photography, and for the ground layer, X-ray photography is being done. Surface layer, ultraviolet photography we do. For pigment layer or the middle layer, infrared photography we used to do. And for the ground layer, X-ray photography we used to do. Ultraviolet photography provides information, indicate difference between the paint medium. Infrared photography describe the difference between the paint pigment. Ultraviolet photography indicates the difference between the paint medium. We should always remember it. Infrared photography provides information, indicate difference between the paint pigment. And the X-ray photography provides information of the support layer. Ultraviolet reflected or direct photography. It's a very technical subject. I am describing in very brief so that we can save the time, friends. Hope you may excuse me. The Retin A18 filter is being used on the lens of the camera. Kodak Retin A18 filter absorb all visible light. Only ultraviolet rays are allowed to pass through the camera to make the image. And this is ultraviolet direct photography. On the left-hand side, this is under a normal visible light. On right-hand side, only ultraviolet light. You can see the disease spots on the skin of this lady. Ultraviolet direct photography. The reflected ultraviolet photography technique records only ultraviolet radiation in the region of 320 to 390 nanometer. I have already told you. All other radiation is prevented from reaching the film or the sensitive medium. A source of ultraviolet is directed to the subject, which will then reflect this radiation back into the camera. With the reflected technique, it is necessary to fit an ultraviolet transmission filter over the lens to prevent any visible radiation from impinging on the film or sensitive surface. Visual radiation, either in the room or reflected from the subject, can thus be ignored because it is absorbed by the filter over the camera lens. And the diagram This is ultraviolet reflected photography. On the camera, this filter, Kodak Retin A18 filter, absorb all the visible light, only permitting to pass the ultraviolet radiation. So in the camera, on the film or on the sensitive surface, image is formed by ultraviolet reflection of light only. So this is ultraviolet reflected photography, and this is another diagram of ultraviolet reflected photography. It is showing the things in the more easier way. You can see here again on the camera is the Retin A18 filter, which it is visually opaque. It only transmits the ultraviolet radiation. So again, the same thing. The retouched area can be seen by this ultraviolet reflected photography. Ultraviolet fluorescence photography, this is very important. It is done in the total darkness. Fluorescence is produced in the visible light. We should always remember that this ultraviolet fluorescence is produced in the visible light. So we'll have to capture this visible light. Use light source which emits ultraviolet radiation only. Kodak Retin 2A or 2B filter on the lens of the camera, which absorb the ultraviolet radiation but allows the visible spectrum only. And this ultraviolet fluorescence photography, these are the points. The illumination of the subject should consist only of the radiation needed to excite the fluorescence. When ultraviolet falls on the painting, it excites the fluorescence, which is always in the visible spectrum. All ambient illumination, room light must be excluded from the subject. Most often, this is done in the total darkened room. Use of exciter filter. This is called the exciter filter, Kodak Retin filter 18A on the light source that transmits only ultraviolet and blocks visible light. Use of the barrier filter, Kodak Retin filter number 2A on the camera lens, blocked ultraviolet light but transmit visible light. That's why I said in the beginning, this fluorescence in the visible spectrum only. The ultraviolet light will strike the subject and excite the fluorescence. The fluorescence would be then recorded on the film or the sensitive surface. Then the diagram like this. On the light sources, we are having the filter 18A, which blocks this is called the black light also. It only permits the ultraviolet light to fall on the paint on the subject. Here it is painting, our subject is painting. When ultraviolet light falls on the painting, it produces the fluorescence in visible spectrum. So when the light reflects back, we are having a filter on the lens of the camera, which absorbs all ultraviolet but transmit only visible light. So that's that. In this way, we can capture the fluorescence which is in the visible light. So these are all the infrastructure. This is another diagram which is indicating the ultraviolet fluorescence photography. And why it is important, friends? Artifacts or documents or painting revealing details under ultraviolet rays when fluorescence is produced under the visible spectrum, which cannot be seen under the visible light. On the left hand side, you have the documentation under the visible light, but if we examine it under the ultraviolet radiation where the fluorescence is produced in the visible spectrum, you can see some other details which are not being seen in a photograph made with the visible light only. Here lies the importance of this infrared and ultraviolet photography, friends. Another example you can see over here. On the left hand side, picture of the painting by visible light spectrum. On right hand side, ultraviolet fluorescence photography, and you can see the arrow. this is the overpainting, which cannot be seen under the visible light photography. And here lies the importance of the ultraviolet fluorescence photography. So in very brief, I have described or discussed with you this infrared and ultraviolet photography and why it is useful for us. Ultraviolet fluorescence photography is one of the most important methods for examination of work of art and archaeology. It is part of the technical photography documentation, and it is used for the examination of many kinds of artifacts. Ultraviolet photography, these things I have already discussed. Cameras, you can say cameras, these digital camera sensors can be sensitive to it once they are modified. These digital cameras, when they are modified, means when there are some ultraviolet and infrared filters in our digital cameras, when these filters can be removed, these ordinary digital camera can be used for infrared or ultraviolet photography films. Most types of the lenses allow long wave ultraviolet wavelength to pass, but absorbs all other ultraviolet wavelengths. Because of this issue, it is best to use specially developed lenses for ultraviolet photography. We have got the special lenses for ultraviolet photography too. These lenses have elements made of fused quartz or quartz and fluorite. A good example of dedicated UV lens is Nikon UV105. This is the special lens made by Nikon for ultraviolet photography. So we have got some special equipment also. We can opt for that. Then ultraviolet photography. When it comes to the digital camera capable of UV photography, one can use, for instance, unmodified Nikon D70 and Nikon D40. These two models can be used very effectively. But there are many other cameras that can be great choice if you remove their internal UV or IR blocking filters. Yes. And there is also Fujifilm FinePix IS Pro digital camera designed especially for ultraviolet and infrared photography. So these are the special equipment designed and manufactured for infrared and the ultraviolet photography. This is ultraviolet fluorescence photography. We photographers use for our creativity. This ultraviolet fluorescence photography can be used for our creativity also. When we talk about light, these are the different four important things: the color, intensity, or we can say the quality or brightness, direction or an angle, and quality. Softness, we can say the softness or hardness. The color, we all know it. An understanding of colors is very useful in photography and theater lighting also. People who work with lights of different colors must know how to produce lights of various colors from a few basic colors. The colors that can be used to make any other color are called the primary colors to produce white light. The primary colors, of course, are the red, blue, and green. In combination, they used to make the white light. Then, when two primary colors mix, they produce a secondary color. Cyan, yellow, and magenta are the secondary colors. A color television uses different combination of colors. We can obtain other colors of light by mixing light of primary and the secondary colors. We can see when we mix red and green, we get yellow. When we mix green and blue, we get cyan. When we mix red with blue, we get the magenta. So primary colors are always red, green, and blue, and secondary colors are the yellow, magenta, and cyan. Colors of the object. When white light shines on non-luminous subject, they reflect some color and absorb all the others. The color of an object is the color of the light it reflects. A red object appears red because it reflects red color of light and absorb all the other colors. Yes, this is how we used to see the colors. The grass of our lawn appears green as it reflects green light into our eyes and absorbs all the other colors. This is very, very simple as it is. Colors of the object. When all colors of light are reflected into our eye, the object appears white. And when all colors of light are absorbed by the object, it appears black. Black objects do not reflect any light. And this is how the light, we call it the color temperature of light. When the light, the illumination is on the warmer side, reddish or yellowish side, we always have the lower color temperature. Just you see in the diagram, when we pass through towards bluish color, the color temperature always used to increase. This is the common phenomena, a thumb rule you can say. Lower the color temperature, light will be warmer. Higher the color temperature of the light, light will be bluer or colder. This is sunrise used to have, because in sunrise and sunset we have the warmer color, the reddish tint of color, because the color temperature of the light that time is the lower, about 2000 degree Kelvin. And incandescent lamp light, it is having 3200 degree Kelvin. Daylight or electronic flash is having 5500 degree Kelvin in between. On the cloudy day, the color temperature increases and it shifts towards bluish light, and it goes to 10,000 degree Kelvin under shade of blue sky. This is the same thing in a different diagram. It is described over there. This is the sunset picture. End of the day is often very warm, heavy towards orange and yellowish. Similarly, tungsten light has an orange color. Because this picture was taken at the end of the day, at the sunset time, when the color temperature of light is on the very lower side. When color temperature of the light on the lower side, it gives the warmish tint. Here you can see in the sky the warm or orangish yellow tint. Similarly, beginning of the day, sunrise is often very warm, heavy towards orange and yellow. Similarly, tungsten light has an orange color when color temperature is again low, 2200 to 2300 degree Kelvin. When we are having low color temperature, it will show us the warmish tint, warm color towards reddish or orangish. On the contrary, before the sunrise or after the sunset, the color temperature of the light is on the higher side, about 7000 to 10,000 degree Kelvin. And when the color temperature is high, the light is bluish in color. So when we take photograph during that time, after the sunset and before the sunrise, where color temperature is on the higher side, we will have the bluish tint into our photographic image. This color temperature is very, very important thing when we talk about the color photography. This is again, it was taken where color temperature was high, and that's why a result is towards bluish or colder tint. This is a combined example. It was taken after the sunset, when in general color temperature is on the higher side, so pictures are looking bluer, colder. But the buildings which are having the tungsten light and the color temperature of tungsten lights are on the lower side, it is giving you the warmer color in the picture. So this is very good example which are having both types of the light, cooler light and warmer light. Light which is having lower color temperature and light which is having higher color temperature. It is very important for photographers to understand the light. Yes, now we have come to the point. Very, very important for photographers to understand the light. Light makes photographic image. Embrace light, admire it, love it, but above all, know light. Know it for all you are worth, and you will know the key to photography. It is said, none by, George Eastman, founder of the Kodak, and very true statement he has given. We all know the word photography is of Greek origin. Photo means it is taken by the Greek word photos, which means light, and graphy by graphos, which means writing or drawing. So when we write or draw with the help of light, it is called photography. And idea of light having some effect on some surface are known very early. You can say in 1614 also, when the green foliage, you take out green plant and put in a room for a few days, then it will be a pale, because plants used to do photosynthesis with the help of light only. When light is absent, plant won't be able to do photosynthesis, and the chloroplast, which is green in color, will not be there. That's why if you put a plant into a darkened room, after a few days, the leaves will be pale. The idea of light sensitiveness of the silver salt. Some noise is disturbing, please. This idea was given by Angelo Sala in 1614 only. The blackening, the sensitiveness of silver salts, silver chloride, silver bromide, silver iodide, when they expose towards light. Actually, the film in the analog era, the films which were used coated with the silver salt, which are sensitive to the light. So this is the old film phenomenon. Different nomenclatures. During the 1816 to 1879, Joseph Neosophore Niepce, we all know the contribution of Joseph Neosophore Niepce in photography. That time he called heliograph, not photograph or photography. He used to call heliograph. Louis Jacques Monde Daguerre, during 1839 to 1857, his process was called daguerreotype, not photography. Then William Henry Fox Talbot, in the given period of 1839 to 1865, he used to call his photographic images calotype and talbotype. Then Frederick Scott, in the year 1852 to 1875, he called his photographic images ambrotype of ferrotype. It is Sir John Herschel who gave the nomenclature of photography and also the negative and positive in 1840. And we are following the same nomenclature today, which were given by Sir John Herschel in 1840. He's Sir John Herschel. In very brief, I'll discuss this phenomena of light for photography. Outdoor portrait. On the extreme left, this is the overcast sky condition, yields a very flat result without any modeling or shadows. When we have such type of the light, we don't have any modeling in our portraiture photography. In the middle, a dull weather, flash can simulate the effect of sunshine. Flash can be adjusted at any direction. A fill-in flash can be used to make more modeling. And here the advantage is that we can use the off-flash camera in any direction. So different sort of modeling can be achieved by the different direction of the flash on this the dull weather. And on the right-hand side, haze sunlight is the ideal lighting for outdoor portraiture, as it causes soft shadows without excessive contrast. So these are the different light conditions for the outdoor portraiture. Then fill-in light reflector. Strong sunlight produces strong shadows and brilliant highlights. Lighting contrast may become very, very excessive. Little unfavorable condition. In the middle sketch, you can see a reflector is being used. As a white card casts light into two dark shadows. Some light which falls on the reflector and reflects back to the object and fill in some darker areas. And we can also use the synchronized flash to fill in the darker area in the contrasty sunlight. So these can be the different adjustments. We can adjust the light for best of our use. Then in indoor portraiture, on the first figure, you can see there is no reflector. Light is coming from one side. The other side of this lady is little darker, very darker, lacking some details. When a reflector is being used on the right hand side, closer to the model, then it will fill the darker side on the right hand side of the face of the model. You can see when we move reflector farther, this illumination will decrease. So when we make our reflector closer, the illumination will be brighter. So we can, this position of the reflector can be adjusted according to our need. So this is the very normal sort of lighting adjustment we have indoor and outdoor portraiture. This can be modified. This is a very specific subject. I am not going deep into this. Some specific light condition. This is the front lighting, when object is being illuminated from the very front. Front lighting illuminates all the shadows evenly and kills texture and modeling, makes it flat. When we illuminate our object from the front, then all the modeling will go on, all the texture will be killed, and will very flat result we will get. This is the condition. And in some specific purposes, we need the frontal illumination of lighting, just like this. This is the very antique army flag, and for wrong, it is in very deteriorated condition, and unknowingly some people put some sellotape on it to in a way, in the impression to restore it. In a way, they are doing more harm than doing good, because sellotape is having the very acidic gum on it. It will further deteriorate this text, this very important textile. To show in a documentation that some sellotape which is having the shining surface, we should use the top lighting, 90-degree angle. Then we'll have this reflection of the shiny surface. So sometimes we need specifically the top lighting. Another, this is the wall painting of some of the fort of Rajasthan, where the golden leaf was used to making this miniature type wall painting. And here also the top light was used to get that golden illumination, much golden illumination. So sometime for some specific purpose we use this top lighting. And oblique lighting shows up the texture naturally by providing natural molding. This is in between, you can say. We will have some sort of modeling or texture by this oblique lighting. Then this is again the extreme. Lighting for texture, very low oblique lighting emphasizes texture by casting pronounced shadows of the surface details and unevenness. This is called the raking light. This is the technical nomenclature. Light is being used as a very lower angle, and it gives emphasis to the texture. The raking light photography is a useful method for examination of work of art and archaeology. Raking light is a technique in which a painting is illuminated from one side only, at an oblique angle in relation to its surface. The angle of light may be 5 to 10 degree only. Raking light helps to reveal the surface texture. It is widely used in the examination of work of art, especially painting and textile. This is the diagram. You can see the angle of light is very, very low. This is the result of the raking painting. The flaking of paint, the tone and twist. This is the close-up of the miniature paper painting under the raking light. You can see all the blemishes, all the deterioration very well. It is due to the raking light. Then this is the part of close-up of the Thanka, a textile Buddhist painting. Again, raking light being used to show this texture and loss of paint. This is very important. Beautiful. This is a sort of Rajasthani painting where for ornamentation they used to have the thicker paint layer. In this motiyon ki mala, you can see thicker paint is being used, and by the raking light, this dimensional effect of this Rajasthani miniature painting can be well taken out. So some special lighting is sometimes very much needed for the technical photography. And these are the different light. We have already discussed it. And the result in these different light. First, one is the raking light. Second is the oblique light. And third is the frontal light. You can see the visual, the difference in the visual. We may have this one by one, we may have this. This is the raking light. Now you can see the uneven surface or textured surface of this textile or embroidered work because the raking light is being used over here. And this oblique light, some of the texture, most of the texture has gone, but some of the foldings and creases you can see. But when you use the frontal illumination, all texture has already gone. So how you are using the light is very, very important, especially in the photo documentation of some technical photography. And friends, this is the angular light. This is the Bada Imam Bada with Mosque of Lucknow, famous Bada Imam Bada. The angular light always give the modeling, and it is very appropriate for architectural photography. We should always do photography of the monuments and the buildings when we are having the angular light coming from one direction. Another ancient monument, this is the Dakshineshwar temple of Kolkata. Here again, the angular light. This is, if we are we may have the frontal illumination, all the modeling of this building structure might have gone. We can see the different contours, different surface difference because there was the angular illumination of light. Light was coming from one direction only. This is a very famous stone sculpture from the Mathura Museum. It is the Mathura Museum stone having some peculiar problem of the layering. In due course of time, outer layering of the stone object used to come. So light was so adjusted, this defect can be seen very properly. You can see this photo documentation of this Buddha head sculpture, and you can feel some layering, outer layer has already been gone. So your lighting should be in a way that what you want from your photo documentation, it should, by seeing the photograph, it may tell you. This is very, very important. Another picture, this is from the Khajuraho Museum. Very soft light on the higher angle was used for taking a photograph of this Ganesh, beautiful Ganesh sculpture. Very soft, higher illuminated light. And these are the bronze, the large size, the human size bronze sculpture. These are the world bronze sculpture for Thanjore Gallery. And these sculptures were put on the gallery, cannot be moved because very heavy, the human size. And it was, the gallery's roof was very high, and some windows, high windows, Roshandan, which we call. And at particular day of the time, I observed appropriate light is coming from these higher windows, and this photograph was taken. A black cloth was put on at the backside to avoid the disturbing background, and the light which is coming from the higher window or Roshandan, and a big reflector was used on the right hand side. So sometimes we'll have to makeshift lighting arrangement when we cannot move the object. This is another object from the Thanjore Art Gallery. Beautiful large size bronzes. If you go Thanjore, kindly visit Thanjore Gallery. Light is divine. Light is coming from the back. Light provides the dimension. This is very important. How we are using the light, this is very important for us photographers. Differential light. Friends, I am sharing with you one of my paper which was accepted in an international conference. The title of this paper was Photo Documentation of the Hidden Lacunae and Fingerprinting of the Paper Painting. It was accepted in the 15th Triennial Conference by International Council of Museum, ICOM, in Paris. Very, very simple method without any sophisticated equipment and accessories. This thing was improvised or invented, you can say. So in very brief, I'll share with you this technique, differential lighting. I nomenclature it the differential lighting. This is my nomenclature. So the principle is lacunae such as paint loss and cracks in the paint, if any, in painting on paper. Handmade rag papers. Ancient miniature paintings are mostly made on the handmade rag papers. These handmade rag papers used for the paper paintings and illustrated manuscripts may contain randomly distributed incursions of the uneven fibers or bits on extraneous materials. अगर आप handmade paper को देखें तो आप देखेंगे उसमें ये जो randomly distribution of the uneven fibers जो है, हर जगह आपको इसका अलग formation मिलेगा, कोई definite formation नहीं होता है. So this is another important point which is a part of this research paper. And ordinarily, these internal defects in paper are not visible. All lacunae in the paint may also not be discernible if it is repainted perfectly or otherwise. It is very unlikely that the paint losses will be similar in two different paintings. That's why I call the paper painting. Principle is, therefore, the shape, size, and pattern of these inclusions and the hidden defects and their spatial distribution can be used as the fingerprint of the painting, as it is impossible for even a master forger to replicate the internal hidden defects in any translucent subject, such as the paper paintings, become visible when it is illuminated from the backside. And the painting can be photographed along with the hidden defects by illuminating from the front side also. So two lights were used, one at the back of the painting, one at the front of the painting. The positioning and the distance is very, very important of these two light sources. The intensity of the light used back and front and their placement may vary from painting to painting, depending upon the thickness of the paper and the paint used. The determine the correct combination of the intensity of these two lights, the source, is the very essence of this technique. This is very important. This method is very simple and requires commonly used photographic equipment. Several miniature paper paintings were photographed by illuminating them from both the sides. This is called, I named it the differential lighting, and the pattern of the hidden defects in each paintings was found to be unique. Now, this is the setup. In between, we have the painting or the illustrated document, one side at the back and one side at the front. The positioning and the intensity, this is very important, how to adjust. This is the core of this technique. Now, you can see on the left-hand side, painting under the normal lighting. On right-hand side, painting under the differential lighting shows the hidden lacunae. Can you see? These portions were retouched. Here you cannot see under the normal light condition, but here you can see these original paint losses which were repainted later on. But these areas can be seen by the differential lighting, two lighting illumination, one at the back and one at the front. So these patterns can be a specific fingerprint of this particular painting because it cannot be seen by the normal visible light. And when anything cannot be seen, it cannot be copied. So these in the two-dimensional object for paintings and the illustrated manuscripts, this differential lighting is the process which can have the fingerprinting of the paper paintings. We having the fingerprinting process of the three-dimensional objects, sculptures, wooden, stone, or the metal sculptures, which by radiography, we can show the internal structure, which can be a fingerprinting of the three-dimensional objects, but we were not having any technique previously for two-dimensional objects, for paintings. And this differential lighting technique can provide us the fingerprint of the paper painting of the paper manuscript. Another example, you can see on the lower side, on the upper side, this is a documentation by the normal light condition. On the lower side, painting under differential lighting showing the hidden lacunae. These paint losses which were painted later on, here you cannot see, but here it is more evident. And this formation, this shape is regarded as the fingerprint of this particular painting. So, friends, and this is the bronze sculpture on the left-hand side, a radiograph of the metal sculpture showing the internal structure. This internal structure is the fingerprint of this bronze metal sculpture. And here also you can see this is a metal sculpture under normal lighting. And this is a radiograph of this metal sculpture showing the internal structure. And this picture of internal sculpture is the fingerprint of this bronze. But for paper painting, previously there was no method of making the fingerprint but for the differential method, here this is the paper painting under the normal lighting and the same under the differential lighting. Here you can see of the paints making this specific design which works as the fingerprint of this particular painting. So friends, I shared with you, this is the technical paper, which was one of my technical paper, which was accepted at one of the international conference. Now the measurement of light. This is again very important point. I may require about 15 or 20 minutes more. I hope you are not.
Yeah. Please carry on, sir. Please carry on.
Friends, you are not getting bored.
Please carry on, sir. Carry on, sir. Very important information.
Thank you. Measurement of light in photography. Measurement of light is very important. Measurement of light, it depends upon the exposure value depends upon the aperture, upon the shutter speed, and of course the sensitivity, the ISO. Our exposure will depend on the persisting light condition of any place where we are doing photography. And these three features, aperture, shutter speed, and the sensitivity or ISO comes into the picture when we talk about the measurement of light. The camera light meter measures the average light intensity of the scene, any scene, which is about 18% of reflection of light. If this reflection of light is more or less than 18%, camera meter will give you the wrong reading. Friends, always remember the camera meter is sensitized for 18% of reflection of light. And if the reflection of light at any given place is more than 18% or less than 18%, the camera exposure meter will give us wrong reading. In above cases, compensation may be done. So we may sometimes overexpose or sometimes underexpose. When we underexpose or when we overexpose, we'll discuss later on. Or we can use the gray card, or incident light meter should be used. Incident light meter reflects the light which is falling on the objects. Reflected light meter measures the light which is being reflected by the object. This is the difference between the reflected light meter and the incident light meter. Our camera has got the reflected light meter. This is the average picture. An average picture or average scene reflects about 18% of light falling on it. Camera meters are standardized for 18% reflection of light. You can say here the lower arrow, the light, incident light is 100%, but the reflected light, which is captured by the camera or measured by the camera in the normal or average picture, is light reflected about 18%. This 18% is very, very important. Suppose this is the chart, the jet black to pure white and in between gray tones. The different reflection of light from the different sources you can see over there. The camera meter, if picture frame is having more darker area, then reflection of light will be less than 18%. Obviously, camera meter will give wrong exposure value. If we go by the camera meter reading, result will be overexposure because the reflection of light is less than 18%. Here, underexposure is required. In this visual on the lower side, where the darker area is much more than the brighter area, if we are taking exposure from the camera meter, which is the reflected exposure meter, we'll have to underexpose it by -2. Then we'll have the correct exposure. On the contrary, when the picture frame is having more lighter areas, then the reflection of light will be more than the 80%. Camera meter will give wrong exposure value again. If we go by the camera meter, reading result will be underexposure. Overexposure required by about plus 2.3 or 2.5 stops. This is the picture which is having the more lighter areas, and the camera meter will give wrong reading because reflection of light is about 80% from here. And if we expose our material with the camera exposure meter, it will be underexposed. So we should be overexposed by this. So this is very important for average light condition. And what is the average light condition? 18% of reflection of light, camera meter is okay. But when this reflection of light is more than 18% or less than 18%, then camera meter won't work. We'll compensate the exposure by overexposing or underexposing. It depends. Here is the gray card. Gray card is very handy. This is on the right hand side is the gray card. It reflects 18% of light. So when we are doing some technical photography, for example, the documentation of the painting, we arrange our lighting condition on the painting, put the gray card, have a reading, and with that reading, expose the painting, and the exposure will be perfect. So when our object is nearby, not far off, the use of gray card is very much recommended. Suppose we are having 3 cards, pure white, gray card with 18% reflection of light, and jet black. And if we expose it with the camera meter, the result will be like this. All will be gray. The white will come gray with the camera meter reading. The gray will obviously gray, and the jet black will also gray. When we have the exposure by the camera meter. If we take photo of black, white, and 18% gray card by the camera metering, measure reflective light, all will look gray like shown above. But if we take the reading by the incident light meter, you can see the incident light meter here. This is the incident light meter. The white will come as a white, the 18% gray as the 18% gray, and jet black will come as the jet black. If we take photo of a black and white, 18% gray, the representation will be same as the object. Here, incident light meter will be measuring light falling off the object, not measuring the light reflected by the object. So if we are measuring the light falling off the object, that is called the incident light, it will be the same if we are taking photograph of the white object or the gray object or the black object. So for very specific lighting, the incident light meter is very, very handy. By the use of incident light meter, we'll have the true representation of the subject. And here is the comparative statement. With the camera light meter, result will be this. With the incident light meter, the result very much identical to the object. So this is very, very important measuring of the light. This light measuring system, this is reflected light. Camera always measure the reflected light falling on the subject and being reflected from here, and camera meter will measure the reflected light. At incident light falling on the object, and incident light meter will measure the light falling on the object, and this reading will be 100% correct. Another example, this is reflected light and this is incident light. And this is some color checker, which is for very specific documentation. We use it, achieve true to life color reproduction, simplify camera and studio lighting balance. We take a photograph with this color checker color board and the gray card, and in the same condition we take a photograph of the object. Then on the screen we can match. These are the known values of the colors and the gray card. We match this, and the same match will have with the object photograph, and every color will be the true representation. Now, photography is the two-dimensional medium. It has got the width and the length, but not the third dimension. This third dimension, that is depth, has to be achieved by the appropriate use of the light. And this visual is very good example where the third dimension, the depth, is being achieved by the appropriate use of the light. Light makes things visible, but photographers make light visible. This is very, very funny quote. You can say, light makes things visible and photographers make light visible. And this visual may be a good example of this statement. Principally, for photographers, it is extremely important to understand the light. Yes, when you understand the light, then you'll be able to use it effectively, and your result will be of very high status or level. In the right light, at the right time, everything is extraordinary. Very truly said by Aaron Rose. This is very peculiar. Due to the light, this displacement of the shadow took place. So it is very true here, in the right light at the right time, everything is extraordinary. A photographer should be able to see the light, understand it, control it, and make it best suitable for the need or requirement. When we understand light, then only we can make most use of it. Photographers should know when, where, and how to make the most of the light presented to create the look they seek. These are some of my works I am sharing with you, friends. In different light condition, different things which were required by me were captured using the different light conditions. Architecture is the learned game, correct and magnificent of forms assembled in light. by the famous architect Le Corbusier. This is the Tile Wali Masjid of Lucknow. Architecture is the learned game, again, the same quote, correct and magnificent of forms assembled in the light. The icon of Lucknow, this Rumi Gate, this picture was taken through the Rumi Gate. This is the entrance of Bada Imam Bada. This is the historical symbol of Lucknow, the city of Awadh. Light makes things visible, photographer makes light visible. Yes, it is true. Know light for all you are worth, and you will know the key to photography by George Eastman. Light is not so much something that reveals as it is itself the revelation. Light itself is the revelation by James Turrell. Light makes photography. Embrace light, admire it, love it, know it for all you are worth, and you will know the key of photography. George Eastman. ये सब रोशनी का खेल है. How you are using the light. This is all about in photography. One of the most important elements of creativity in photography, light, is what allows us to convey information and, more importantly, emotion. This visual or this image is a good example. The emotion captured by the use of light, the appropriate use of the light. Another example of that, one of the most important elements of creativity in photography, light is what allows us to convey information and, more importantly, emotion. This is my daughter when she was about 4 or 5 years old, very old photograph of mine. Once you understand light, you will have the knowledge to create a wide variety of creative images. Again, once you understand light, you will have the knowledge to create a wide variety of creative images. Same thing, desert is a place. I love doing photography in desert. Light plays a very, very important role in this desert texture. Once you understand light, this is very important. Then you'll be able to use it effectively to make your creative images. Photographers should be able to see light. Another very important statement, photographers should be able to see the light. 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 The appropriate light. Light suitable for him or her. Light always follow the path of beautiful. Unknown saying. Yes, it is true. Light always follows the path of the beautiful. Light always follows the path of beautiful. Yes, it is beautiful. No doubt it is beautiful. And light playing very important role to make it beautiful, friends. I am forever chasing the light. Light turns the ordinary into the magical. Trent Park. Very truthful quotation by Trent Park. Photographer should be able to see the light. I am forever chasing the light. Light turns the ordinary into the magical. To see the beauty is to see light. Victor Hugo. I am forever chasing the light. Light turns the ordinary into the magical. Yes, indeed. To see the beauty is to see the light. Light always follows the path of beautiful. Yes, indeed. Travel light, live light, spread light, and be the light. In the right light, at the right time, everything is extraordinary. Aaron Rose. Once you understand light, you will have the knowledge to create a wide variety of creative images. Light makes things visible. Photographers make light visible. A photographer should be able to see the appropriate light. Chase the light. A photographer should chase the light, should be able to chase the light. Light makes things visible. Photographers makes light visible. Light always makes things beautiful. Light makes things beautiful. Light, light, and light. Light is important everywhere. I am forever chasing the light. Light turns the ordinary into the magical. Again, the same statement with a different visual image. Don't stop chasing the light. Friends, don't ever stop chasing the light. We should chase the light. The place where light and darkness begin to touch is where miracle arise. Robert Johnson. You have to find what sparks a light in you so that you in your own way can illuminate the world. To see the beauty is to see the light. John Ruskin said, all the grace of the window is in the outline of it, light. The place where light and darkness begin to touch is where miracles arise. No light for all you are worth, and you will know the key to photography. To see the beauty is to see the light. The place where light and darkness begin to touch is where miracles arise. The magic of light, the miracle of light. It is said, light is the shadow of God. Light is a metaphor of God. Light is a synonym of God. To love beauty is to see the light. Light is shadow of God. In the right light at the right time, everything is extraordinary. Yes, friends, we should be able to chase the light. Let light shine out of darkness. The lighted zigzag path of a jungle. Give light and people will find the way. Sometimes it is very confusing, but light will guard our way, the right way. This is very fun. We are at the end of our presentation, and with this very funny visual, the importance of light in photography. You can see the importance in this visual. This is the funny visual, friends. It shows how important is light in photography. And with this sunrise image of Dudhwa National Park, I quote Trent Park, where he said, "I am forever chasing the light. Light turns the ordinary into the magical." Friends, thank you so very much for listening me so patiently. Now I stop sharing my screen.
Oh my God, really, sir, you have taken a lot of pain and a lot of time to really frame this very unique presentation. I can tell in few words, sir, this showing in-depth knowledge of light, starting from theory to the actual photo shoot, is really miracle. And the way you have presented, particularly the 15% part you have touched, is very important. And most of us do not know that our camera sees only 18% gray. Our camera never sees any color.
Camera measures
only 18% gray, not green, red, or anything. To make it look differently, we have to go for compensation. And then the way you talked about for the darker light, for darker object, you have to go for a minus compensation, exposure compensation. For brighter object, you have to go for a plus compensation. And that is the crust to know the light. Thank you very much, sir.
My pleasure always, and thank you very much, friend, for listening me. For I have taken about 2 hours, and to be with me for 2 hours, I am really obliged. Thank you. Umesh ji, how are you? Namaskar.
Namaste, sir.
कैसे हैं आप?
I am fine, sir. I am fine.
So
ऑनलाइन इंस्टाग्राम पे तैयारी कर रहे हैं.
कपूर साहब को नमस्कार.
Hi Anil, hi. Outstanding.
कपूर साहब को नमस्कार.
Thank you so much.
कपूर साहब हमारे
नमस्कार. Sir, thanks for this master stroke.
Yeah.
I think.
And
no one can think about light so many things.
And that's why I have named it master's classes.
See,
one of the real master's class.
Yes, definitely, it's a real master class.
Yeah. Akhil ji,
hello.
Hi, thank you, Anil ji.
Akhil ji, अपना माइक अनम्यूट कीजिए. अखिल जी. उमेश भाई, वेलकम.
नमस्ते मुकेश जी. नमस्ते.
Yeah, so nice of you.
थिरीज जी को भी देख रहा हूँ मैं. थिरीज जी नमस्ते.
हाँ नमस्कार सर. वैसे कैसे हैं
अखिल जी? हाँ कुछ बोलिए. Say something about the presentation.
सब वंडरफुल. आज तक सिर्फ लाइट और कैमरे से खेलते आए, ये नहीं समझ में आया कि लाइट का रोल क्या होता है. ये समझ में आया. और एक बात जानना चाहूंगा, जो पहले इंफ्रारेड फोटोग्राफी कुछ ब्लैक एंड व्हाइट में हुआ करती थी, जिसमें रेड फिल्टर यूज करते थे ब्लैक एंड व्हाइट फिल्म के साथ, और फिर वो इंफ्रारेड में कहलाती थी या नहीं कहलाती थी, आप क्या कह सकेंगे उसके लिए?
जी, इंफ्रारेड में जो फिल्टर यूज करते थे उसका डार्क रेडिश कलर होता था. ये फिल्टर जो था वो जो विजिबल लाइट थी उसको एब्जॉर्ब कर लेता था. ओनली जो है इंफ्रारेड लाइट को परमिट करता था, वो लेंस के थ्रू सेंसिटिव मटेरियल या फिल्म पे जाती थी. तो ये सिर्फ इंफ्रारेड से इमेज फॉर्मेशन होता था. और ज्यादातर इंफ्रारेड फोटोग्राफी जो है कैमरे को ट्राइपॉड पे माउंट करते हैं, क्योंकि एक्सपोजर जो है वो लॉन्गर साइड में होता है, क्योंकि जो लार्जर पोर्शन है जो विजिबल लाइट का वो तो हमारे इमेज फॉर्मेशन में यूज नहीं हो रहा है. ओनली इंफ्रारेड रेडिएशन यूज हो रहा है. तो एक्सपोजर वैल्यूज जो थी, एक्सपोजर टाइम थोड़ा ज्यादा होता था. तो इसीलिए हम कैमरा ट्राइपॉड पे कैमरा को माउंट करते थे. और इंफ्रारेड में फोकसिंग थोड़ी सी शिफ्ट होती है. अगर आप अपने पुराने लेंसेज में देखें तो जो फोकसिंग स्केल होता है उसमें एक रेड मार्क होता है. तो दैट इज फॉर इंफ्रारेड। अगर जब आप विजिबल से फोकस कर लीजिए और इंफ्रारेड फोटोग्राफी कर रहे हैं तो उसको शिफ्ट उस रेड मार्क पे कर दीजिए। तो ये थोड़ा सा टेक्निकली डिफरेंट है अल्ट्रावायलेट इंफ्रारेड फोटोग्राफी का।
इंफ्रारेड फोटोग्राफी
और इंफ्रारेड फोटोग्राफी के लिए जब एनालॉग सिस्टम हम यूज करते थे तो स्पेसिफिक फिल्म होती थी। ये ऑर्डिनरी अल्ट्रावायलेट फोटोग्राफी के लिए तो हम ऑर्डिनरी फिल्म यूज कर सकते थे, लेकिन इंफ्रारेड फोटोग्राफी के लिए स्पेसिफिक फिल्म आती थी। ब्लैक एंड व्हाइट अलग आती थी, कलर अलग आती थी।
और इसको डिजिटल कैमरे के लिए इंफ्रारेड फोटोग्राफी के लिए आप कुछ सजेस्ट कर सकेंगे? उस फिल्टर जो आपने बताया उसके अलावा कोई तरीका?
हाँ, मैंने आपको बताया ना, डिजिटल कैमरे में ये अल्ट्रावायलेट और इंफ्रारेड एब्जॉर्बिंग फिल्टर होते हैं, इसको निकालना पड़ेगा, तब आप डिजिटल कैमरे को अल्ट्रावायलेट और इंफ्रारेड फोटोग्राफी के लिए यूज कर सकते हैं। कुछ मॉडल आते हैं ऐसे, कुछ मॉडल ऐसे डिजिटल में आते हैं कि जिसमें ये फिल्टर नहीं होता है, वो तो बहुत आसानी से हम यूज कर सकते हैं। अदरवाइज जी डिजिटल कैमरे में से हमको ये अल्ट्रावायलेट और इंफ्रारेड फिल्टर निकालना पड़ेगा, तब हम यूज कर सकते हैं।
Sir, I have one question.
Yes.
I have one question. You use the word modeling. The modeling of light, does that mean the gradation of light?
No, the gradation light. Modeling means showing the contours of the object.
Sir, can you please speak? Repeat. Your voice is cracking.
Modeling means when it shows the contours of the object.
Contours of the object.
Yes.
Okay, the contours of the object. Okay.
Yes.
And sir, would you please suggest some kind of a reading resources what you presented today?
Anil should make a series of this and distribute it to everyone. Mukesh should distribute it to everyone.
If you go on Google Baba, it will provide everything, sir. So these days it has become very, very easy.
No, nothing. Anil, nothing like what you presented today.
Everything will be there.
Sir, I have one question.
अरुण जी प्लीज।
सर, आपका कई फोटो में हमने देखा कि जिसमें डार्कर साइड में आपका जो अभी आपने हमको समझाया कि केल्विन टेम्परेचर ऑफ द लाइट या पावर ऑफ केल्विन, तो कुछ डार्कर साइड में ऐसा है कि वो हायर केल्विन में जा रहा है, और उसी फोटो में कुछ ऐसा लाइट भी है जो मिडिल केल्विन या लोअर केल्विन में जा रहा है।
देखिए अरुण जी, जब आप ब्लैक एंड व्हाइट फोटोग्राफी कर रहे हैं तो ये डिग्री केल्विन, द कूलर लाइट और वार्मर लाइट का कोई फर्क नहीं पड़ता है। सिर्फ जब आप कलर फोटोग्राफी कर रहे हैं तभी इसका इफेक्ट सामने आता है। मैं
कलर का ही बात कर रहा हूँ सर।
जी।
तो उसमें देखें कि जो डार्कर पोर्शन है वो थोड़ा ब्लूइश टिंट में आ रहा है, तो क्या हम लोग के पास ये ऐसा स्कोप है कि हम लोग नॉर्मल लाइट में ही टेम्परेचर केल्विन को ट्रिक करके ये इफेक्ट ला सकते हैं?
अभी तो आप रॉ में इमेज फॉर्मेशन करते हैं, रॉ में जाइए और जो भी कलर टेम्परेचर आपको चाहिए सॉफ्टवेयर में अचीव कर लीजिए।
वो पर्शियल अचीव किया जा सकता है सर?
जी। आज रॉ का यही तो इम्पोर्टेंस है। कोई भी कलर टेम्परेचर जो आप चाहते हैं वो आप अचीव कर लीजिए अपनी इमेज में। यू कैन चेंज द कलर टेम्परेचर, एंड व्हेन यू चेंज द कलर टेम्परेचर,
एक ही फोटो का कोई पर्टिकुलर पोर्शन में हम अलग से उसका टेम्परेचर कंट्रोल कर सकते हैं?
देखिए, मैं जो फोटोशॉप यूज करता हूँ सॉफ्टवेयर, और आई एम नॉट एन एक्सपर्ट ऑफ फोटोशॉप। आई थिंक मिस्टर उमेश गोगना इज देयर, he may advise you about this selective change of color temperature.
उमेश भाई, अभी उनका वीडियो ऑफ है सर।
अच्छा, चलिए कोई बात नहीं।
बैठ वो क्या है कि इसमें अगर आप लेयर बना के काम करेंगे तो यू कैन चेंज द डिग्री केल्विन सेलेक्टिव ऑल्सो। एक ही इमेज में 3 पार्ट में 3 तरह का आप जो कलर टेम्परेचर यू कैन डू इट इन 3 लेयर्स। आप तो जानते हैं लेयर पे काम करना, कोई दिक्कत नहीं है। कपूर साहब,
सर
प्लीज से समथिंग फ्रॉम कोसानी।
Sir, I tell you, this was one of the best webinar I have seen in my life.
Yes,
People from all over the world can say anything, but just to talk on light and the codes and the photos and the images which Anil produced, you will be surprised. They were as old as 60 or 50-year-old photographs also.
Yes,
around
yes,
50 years
some very old,
photographs
yes.
also. I don't know how he collected all these things, and I think there was no webinar in the country or anywhere in the world like this. People can talk about
Don't say like this, Trish. Thank you for your appreciation.
I tell you, Anil, this is a eye opener for the world that there is a person like Anil Risal Singh in India, and he's a friend of mine.
Yes,
So,
yes,
you know,
For your
yes.
nice words. Thanks for your appreciation, Trish.
ऐसा वेबिनार हो ही नहीं सकता और सिर्फ लाइट पे कोई भी व्यक्ति इतना नहीं बोल सकता।
हम बता रहे हैं कि
And
ये जो आज का प्रेजेंटेशन है, ये प्रेजेंटेशन इतना रिच है कि इसका कोई जवाब नहीं है। एंड
Mukesh ji, thank you.
थैंक्स लॉट टू अनिल सर कि उन्होंने हमारी बात को एक्सेप्ट किया और वो बहुत हार्ड वर्क की है। आई कैन सी द काइंड ऑफ इंफॉर्मेशन ही हैज कलेक्टेड, मे बी फ्रॉम हिज ओन डिपार्टमेंट लाइब्रेरी और गूगल बाबा आल्सो, but the way he has presented, starting from the basic theory to the ultimate photographs, showing the you can say changing of light. This is a wonderful presentation.
Mukesh ji, rather, if he presents this thing to some university, he will be awarded doctorate for this.
Oh my God! Don't say like
Definitely.
this. Don't say like this.
You know, almost like a research paper. Almost like research paper.
Mukesh ji, Trish always exaggerate the things. You
नहीं
know?
ऐसा नहीं है सर, ऐसा नहीं है सर। एक जो आपने सर दिखाया ना फोटो डॉक्यूमेंटेशन को कैसे करते हैं,
जी।
by giving backlight and front light to get the complete thing visible.
Yes, Mukesh
वो
ji,
भी
that
बहुत
was
बढ़िया।
my paper accepted
Hello.
in
Yeah.
this international conferences at Rome.
That was very informative. वो पार्ट हमने आज आपसे सीखा। फैक्ट ये है सर। उमेश भाई आप कहाँ हो? Yes, you are here. Yes. Please say something.
एक्चुअली मैं थोड़ा सा मिस किया था क्योंकि मेरा भी रात को लाइव सेशन है रफीक सैयद साहब के साथ में, तो मैं थोड़ा प्रिपरेशन 10 बजे है 10 o'clock, तो उसी की प्रिपरेशन में था। लेकिन वो जो रिलीजियस के बाद वाला जो जहाँ पे मैंने ज्वाइन किया था, वो रिलीजियस एस्पेक्ट जो इन्होंने लाइटिंग के लिए बताया था, जस्ट वहीं पे ज्वाइन किया था। उसके बाद में पूरा
ज्यादा मिस नहीं किया आपने, ज्यादा मिस नहीं किया
आपने।
उसके बाद मैंने पूरा देखा है एंड बहुत आपने इसको मतलब बेसिकली मैं इसको थीसिस ही बोलूंगा पूरा का पूरा। आपने तो जो हमारा स्पेस था, लाइटिंग का स्पेस को ओपन करके रख दिया पूरा का पूरा।
थैंक यू सो मच फॉर योर नाइस वर्ड्स।
एंड जो इसमें से निकालना चाहता है वो बहुत कुछ निकाल सकता है। एंड मतलब आपने डॉक्यूमेंटेशन से लेके टेक्निकल से लेके साइंटिफिक से लेके सब कुछ बता दिया, स्पेक्ट्रम तक पूरा बता दिया लोगों को, जो कि मतलब ज्यादातर लोगों को नहीं मालूम होता है।
Yes.
स्पेशली थैंक यू, बहुत ही अच्छा।
माय प्लेजर ऑलवेज। थैंक यू उमेश जी फॉर योर टाइम।
फ्रेंड्स मीट उमेश गोगना जी। He will be our master's class expert in the month of July. We have planned to go for a astrophotography classes. Astrophotography part 1 will be in the month of June. Astrophotography part 2 will be in the month of July.
Looking forward.
Yeah. Now I'll request Arun Kumar Banerjee to give vote of thanks.
Thank you, sir. Respected Sri Anil sir, our distinguished guest and speaker of the day, Adit Agarwal sir, and all the senior photographers, including my president, Mr. Mukesh Srivastava. As you all people know that DCC started, actually took this effort to make our imprisoned photographers, those are imprisoned now today in pandemic days, who started these efforts to provide something new for them. And that was the result of our last webinars, which you have seen. That was a great success for worldwide. And the second effort that we have taken, that is the master classes, and these all efforts are the result of the thoughtful planning of our president, Mr. Mukesh Srivastava. And I also thank for that, sir. We have got a great opportunity to learn from the masters for your such planning. And I am very much thankful to all of you, especially sir, Anil sir. It was a spectacular presentation, what Sir Gagna said, Umesh Gagna says that you have touched all the aspect of lighting, from the mythological part, from the scientific part, and basically I was initially was thinking what is the relation between this our photography and this mythological part and the scientific part of the light. But after coming to the end, I understood all these things. Why you have mentioned such things in the beginning? It's a masterpiece, sir, and I think it is really a thesis.
Thank you.
Really, this is a precious thesis, and I can raise my hand because I know that this is the first of its kinds from you. I think.
Yeah.
But
Very true.
Before this presentation, I think you haven't presented this thesis to anywhere else in the world.
Yes, this is the first time. This is the first time I'm having.
This was prepared for Dharmat Camera Club.
Yes.
Master's class.
Specifically prepared for DCC.
And we are very much glad to for being that we are able to share these things with all of you. And again, I am thankful to everyone for joining this. And this is I think this is the webinar that the greatest participants are present there. That is 70 participants were there.
72.
It's not 72 participants are there. So it's a grand success, sir. And I am very much thankful to Anil sir. Pranam, sir. I don't deserve to say you thank. I don't deserve to say you thank. I can only say you pranam, sir.
Big applaud for such kind of presentation.
Thank you so very much, friends.
Okay, friends. Goodbye. We will be having once in a month such kind of master class from the experts.
Thank you so much, sir. Thank you so much, sir.
Okay.
Okay, Yadavji. Bye. Namaskar.